Man, don't you hate getting stuck in the void between galaxies? Like, honestly. There's Andromeda over there. We were there last episode. There's the Milky Way. There's the large and small Magellanic Clouds. Where are we gonna go now? Oh yes, more space engine. Ha ha ha. Well, let's just bugger off and see if we can find another galaxy to go to. Actually, wait a minute, where's the Milky Way? Is that the Milky Way? That's the small Magellanic Cloud. I mean, that's the Milky Way. Alright, we're gonna keep that in our viewfinders. What's that? Oh, it's Andromeda. Of course it is. Now then, we're gonna go to some random galaxy, and we're just gonna like... I'm gonna pick up now the Pegasus Galaxy isn't real. That's kinda sad. Can't go all Stargate here. Stargate Atlantis. Yes, each dot here is a galaxy, and each galaxy is full of stars that we can go to. And I wonder if I can see the actual supercluster, like the mannequin figure. Okay, I can. Oh, that's kind of sad. There's a, in our local cluster, at a certain angle, the galaxies look kind of like a mannequin, like a person. I guess you can kind of see it. You can kind of see it when I spin it around, but not really. I don't know, it's not important. It's just a coincidence. Actually, the galaxies here, you can see how they clump together in streamers kind of patterns, or the theory about that is that they actually clump kind of like like soap bubbles, where it's like you have the bubble and then like where the bubbles meet, that's where galaxies form, kind of thing. So you have like these big open bubbles of nothing surrounded by streamers of galaxies, and they're not exactly sure what causes that pattern. However, looking at models of what dark matter would be, and like where dark matter's gravity is in relation to the galaxies are, they've actually seen a correlation between the galaxies and the dark matter. So there's actually a thought that the galaxies clump like that because of dark matter. And there's other theories that go along with this as to what dark matter actually is. Is it actually matter, or is it something else? Another thought is that the dark matter is actually just matter. Dark matter itself is actually just the gravity seeping to our universe from a parallel universe that shares the same space in a different, I guess you could say, a temporal plane or something like that. Or some think that it may be another membrane universe kind of thing. I can go on for a long time discussing multiverse and whatnot. So yeah. Anyways, we're in a random galaxy, and I'm on a random cluster inside said random galaxy we're going to explore. I feel like being more sciencey today, so more sciencey stuff instead of just bantering on about absolutely nothing, which is also fun. And I'll continue to do. So yeah, I usually make my videos for my own entertainment, but I'll also make them depending on enjoyment for others. And these space engine videos tend to have a fair bit of enjoyment from people. I've noticed a lot of people like them, so I'm not afraid to actually do them for you guys, because if you guys enjoy them, yeah, sure, I'll do it. Ooh, a frozen time. We live a lot of time. Cool desert. Yeah, again, I make these videos for the enjoyment of myself and for whoever gets a kick out of them. So, if you guys like these space engine videos, then yeah, I'll keep making them, because I love this program. Anyways, as I was saying about the dark matter thing, holy crap! Look at all the moons, Batman. Show some of these moons. Actually, they look pretty generic, but that's okay. Anyways, yes. Because they keep trying to figure out what dark matter is, and since you can't detect it directly, you can detect its gravity, its gravitational influence. So the theory that it's actually just the gravity seeping in from another universe is actually an interesting one. Because you can think of it kind of like this. Imagine you have a roll of toilet paper. Okay, each square of toilet paper is a universe. Now take your wet hand and squeeze the toilet paper roll. Now, the water will seep through, and your handprint will be visible on a whole bunch of the layers going down. Although your hand only touches the top layer, the influence of your hand is still visible through all the other layers. So that's kind of what they're going at, that the gravity permeates into the other universes. I know, I can explain universes too. There's different types of multiverse. There's membrane universes, which go into M3 and superstring. There's temporal multiverses, as well as I think 10th dimensional universes. It's complicated. And this is an interesting little asteroid. Let's land on it. Oh yeah, G. Hahaha. Now, a lot of this actually goes to explain a few things. Because one thing that, a lot of people say that the fourth dimension is time. Well, that's all well and good. However, all 11 other dimensions are physical dimensions, and time's a temporal dimension. And that doesn't work very well with how everything is supposed to work, because when you have a temporal dimension, it's not a point, it's not an object, it's not a reference. Because it's like the universe, for the most part, can be described, or the dimensions can be described as a point or a line segment connecting 2 points. So it's like the second dimension is length, so it's 2 points connected by a line. The first dimension is a point, so it's just like a point, basically. Third dimension is length and width, so it's 2 points converging. 3 dimensions is height, so it's length, width, height, or depth, I should say. So that's kind of how you can say it, but with time, you just have time, and it's a temporal dimension. That makes the other ones kind of shaky, and nobody likes that. So there's actually a thought where you can have time converge with something called anti-time. So you have time and anti-time, which is basically a line converging between 2 points going infinitely in each direction. And by doing this, you can actually have the fourth dimension a physical dimension, albeit a weird one. And using that, you can it actually solves a lot of problems. And I kind of forget why I got on this tangent, because I'm trying to figure out the correlation between multiverse. Right, time travel, temporal multiverse. The most notable multiverse. Actually, 1 minute. This is a really interesting crater pattern. Yes, I will talk about the game, but I'm also talking about science because I like science, and I'm also one of those people who have nothing to do in his life. And I just spent the last 4 years developing a warp drive and a time machine. I'll get into that later. Anyways, back to what I was saying. What was I saying? Yeah, temporal multiverse. They're the most easily noticed, they're the most easily known or easily to visualize universes. Basically, it's just for every action, for basically every choice, chance, and action, there's an infinite number of universes that come depending on what choice you do. So in other words, there could be a universe that is exactly like our universe in every single way throughout all time. However, an electron moves left instead of right at one point, like that kind of thing. Or you can have a universe where everything is completely different, in formation, when the Earth never formed, the Earth did form, but the dinosaurs never died. There's a whole bunch of stuff depending on choice and chance. And this also actually can be used to make time travel not violate anything. Because, like the grandfather paradox, you go back in time, you kill your grandfather, you go forward in time, well, how the hell did you do it? Because you killed your grandfather, so you shouldn't be there. That only works if you have a linear timeline with a singular universe. But if you have the temporal multiverse, that can be easily explained by, you go back in time, you kill your grandfather, you go forward in time, however, when you go forward in time, you're actually entering a parallel timeline in which you never exist. So you actually did, in fact, kill your grandfather, but now you are, you're prospectively changed in your temporal location kind of thing. I wrote a paper on it once that I didn't submit to anything or anyone or show anyone because, again, I'm working on my master's or my bachelor's in biology currently, going to astrobiology, and being just a university student, nobody cares about my opinions or my ideas. Then again, I'm the kind of guy who, even in grade 5, I was writing about basically how to colonize Mars was one topic. I wrote a large thing on it. My teachers were like, oh, wow, this is nice. And I had one teacher who was like, this is legit. It's like, well, no shit, it's legit. I don't know what I'm talking about. Anyways, we're going to depart from this little asteroid because it's interesting. But we need to go elsewhere, so this isn't boring. Let's go there. Anyways, yeah, so with the temporal multiverse, it solves a lot of problems within physics, and it can also kind of be almost be validated. Like, there's a few things that can be done, but one thing that's showed up in recent times is that time travel, it depends on who you talk to, it could be possible, impossible, but it's, for the most part, it is possible, but it works like most other things with loopholes. Time travel into the future is quite easy. You just accelerate. Oh, okay, 1 minute. Oh, there you go. You just accelerate until you're close to the speed of light, and then time dilation takes over. Time for you ticks slower, so you basically spend like a week traveling at this speed, and you end up being hundreds of years in the future kind of thing. Or you orbit near a black hole, and the gravity does the same to you. Same deal. In fact, for everybody, time travel using gravity has been validated because its GPS satellites would not function without it. Because, fun fact, when they first launched GPS satellites, this is an interesting little planet, those ring system. When they first launched GPS satellites, they didn't work properly, and like they were always getting out of sync, and they were like, well, what the hell? And it turns out because the clocks on the ground were trying to sync with the clocks on the satellite, but because the satellites were farther away from the solid, like the core of the Earth, as opposed to the clocks on the ground, the clocks on the ground were traveling very, very, very point decimal whatever slower than the clocks on the satellite. And although it's barely noticeable, like it's a barely noticeable change, it was enough of a change that the clocks did go out of sync enough that it caused problems with the GPS satellites. So people who were like, oh, time dilation, how you can't prove it, time travel, all that stuff, it's like, well, it's kind of, if you ever used a GPS on your phone, you're validating relativity. So that's a fun fact, and this is a very barren environment. Let's go over here. Mountains? Ooh, what's this? I like it. This is like looks like some kind of pressure ridge or something. Cracking on the surface. Wow, this is cool. On some galaxy somewhere. I don't even know where the Milky Way is anymore. So yeah, there's that whole concept. Going back in time is the tricky part. That's the one that everyone's like, I don't know if you can do that. And there are some ways to do it that don't violate anything. However, they do have catches. For example, you can use a closed space-like curve, for example, which is a phenomenon that supposedly appears around fast-spinning black holes, or these things called cosmic strings, where it's basically time has been curved back in on itself into a loop, and if you travel in a reverse order around that loop, you'll actually end up farther back in time. But that only works as far back as when the loop was first created. So an example to make one of these was this thing called, I forget what it's called, but it involved a giant cylinder in space. Basically, it's like this idea you make a cylinder that is hundreds of kilometers across and like billions of kilometers long, and you spin it almost as close to the speed of light. And near the surface, it will actually grab the fabric of space and tug on it and make a closed space-like curve. And then a spacecraft would just have to rotate in the opposite direction of the cylinder's rotation, and it would actually go back in time for every rotation. Unfortunately, with that, it would only go back you could only go back as far as to when the cylinder was first spun up, kind of thing. There's a similar experiment with this one fellow. He's trying to use light to do the same kind of thing, make a closed space-like curve. But again, you can only send information back as far as to when it was first turned on. What is this? It's like it's broken. Now, that's what it's called a cosmic string, because they're kind of like spaghetti black holes, I guess I could call them. It's basically like it's like one atom wide, but billions of kilometers long, and it has such massive, mass that it basically it's just like a string black hole. I don't know how to describe it, but we haven't found them yet, but they supposedly formed at the beginning of the universe when the Big Bang occurred and all that jazz. So if they have, and they would probably have closed space-like curves around them just because of their properties. So if you could find one, you could technically go back in time as far as you want, basically, until a few seconds after the beginning of the universe. Actually, probably a few minutes. Actually, there's some stuff going on with the cooling, and that would be interesting and all. But of course, you'd have to find it, get there, and then do it, and then getting back, you'd have to do relativistic stuff. And I don't know. I've done some thought experiments and some work into make it and to basically, abusing anti-time to make an open space-like curve, which it's a curve, but it bends back to different points and everything. I don't know. I'd rather not get into that right now because it's very theoretical. I have no credentials, so even if I'm right, no one would care. And yeah, this is a very cracked up planet. So yeah, there you go. We went from multiverse to we went from dark matter, multiverse, time travel. You've basically just learned, well, what I do with my spare time, which is be that smart guy who doesn't seem all that smart because I stutter, and because I'm not very social, and because I'm bad at math, yet I'm genius with other things. Oh, well, I'm not bitter. I'm just here to be entertaining and hope that somebody learns something. Oh, there's a lot of these really massive orange giants I'm noticing. We bump into them all the time. What's this? I guess I could probably go back to the multiverse and continue on. Like, I explained basically temporal multiverse. I could probably go back to the other ones. See here, fourth dimension, fifth dimension is another universe parallel to our own. I think sixth dimension is the sixth dimension is like a branching of universes or something like that. I don't know. It kind of goes up. I'm pretty sure like the seventh or eighth, one of those two, is basically every universe or every possibility within our universe due to choice and chance. Then you basically go up to like the 10th dimension, which is every single universe which contains every single possibility. So you can basically get an infinite number of universes within an infinite number universes, basically. So yeah, it's like a box within a box, and you can basically do stuff like that. And this is an interesting colored. It's like it's airbrushed. Huh. Again, I am not a physicist, although I'd like to believe I am. I am not. So I'm probably right on a lot of this, but again, I haven't studied up on the dimensions in a while. And I'm pretty sure I know that the 10th dimension is every conceivable universe, or every possibility within every single possibility. Stuff like that. I don't know. Believe it or not, my area of focus is biology. I want to do astrobiology, the search for life on other planets. And I was actually working on, a while ago, the possibilities. Actually, just a few days ago, I was talking with a friend, and I was trying to explain how alternative biochemistry would work. Because we're carbon based. Oh, we've already been to this type of moon before. I don't have much time. It's like we're carbon based, so we're accustomed to things like our environment. However, you can have carbon based life in more extreme environments. For example, Titan has a liquid methane lakes, and it's super cold with a highly nitrogen atmosphere, but it still produces the organic chemistry which can form life. And you can use liquid methane in place of water as the solvent for the organic compounds. So in theory, life could form on Titan, and may have already formed on Titan, or may be forming on Titan, which is why they actually want to send a probe to Titan to land on the lakes and float around. So yeah, that's an example of having organic meaning carbon-based life living in a extreme environment compared to life here. But I was thinking about silicon, because most of the elements in the periodic table could potentially form a complex structure like a genetic code. But I was working on silicon because it's the most, easily, theorized. And I came up with kind of two possibilities on how it would work. If you want a life system similar to ours, like in processes and whatnot, I was thinking you'd have to have a silicon-based life form that exists in a fairly high temperature environment. I haven't worked out what solvent would work, like what would be the universal solvent, but all I know is it would probably be a very high heat environment, which would provide the energy for it all to work. That's exposure. And then I was thinking, if you want a more bizarre explanation of how silicon-based life would work, you could do the circuit model, as I call it, where it's basically the silicon-based life operates more like a circuit board than it does in like a biological system where it exists in a very cold and highly charged environment. Basically, like it would be like a crystalline plant in a way, where it basically does electrical ion transfer in place of to carry out life functions, kind of like how we do protein and whatnot synthesis. And I thought that it could potentially use ionized particles and charged particles from magnetic fields from either a star or a neighboring gas giant like Jupiter. Like, for example, a planet or a moon like Io, which orbits within the radiation belt. Something like that, where you'd have a moon that has no atmosphere, is far from its parent star, but still within a magnetic belt where it can, a scorched desert, where it can still get these charged particles, which would basically use, kind of like plants use light for photosynthesis, only would be electrosynthesis, I guess. I don't know what to call it. Again, I don't know. I just work. I don't have much of a life, so I science when I'm bored. I have a little home lab. I do stuff. I do a lot of at-home science, a lot of stuff like that. A lot of rocketry stuff and engineering too. So I do practical science, but I also prefer the theoretical. So yeah, we're now at 20 minutes. I've basically given you a lecture on a number of topics. If you enjoy this more sciencey format, where I basically go to different planets and I talk about the planets, which I wish I talked more about the planets I was visiting. Sorry about that. But still, if you like the more sciencey aspect, where I'll actually talk about the possibilities and stuff, like within this, like talking about the universe itself, like while I'm doing this, let me know. If you want me to just go back to being goofy and doing nothing, well, I can probably do a bit of both, where I'm goofy and sciencey at the same time. It's the best way to do it. I think Carl Sagan had it best, because he would blend humor into his stuff beautifully. So yeah, we're going to land here to end this video. I would like to do more, and if you'd like to hear more about other topics, let me know. I'm well versed in most science topics, I guess. But actually, this is how much temperature here? 124 Kelvin. This is actually a good example for the silicon base I was talking about, because it would probably need to exist in an environment similar temperatures around this. I would think a little bit more, actually, to get this, what I'd expect to work. But yeah, I don't know. Maybe these rocks work. Again, it's all theory at this point. I have not found silicon life, although I'd like to keep looking. It would probably be devastating to life on Earth, so we wouldn't want to do that. We have an Andromeda strain situation. But we're pretty sure panspermia, if it's real, is very uncommon, which is, if you don't know, the transit of life, or life materials between planets through meteors and comets and stuff. I can talk about that in another episode, probably next episode I'll talk about that, because it's very fascinating and I love it. But now we're 22 minutes, we're 2 minutes over time. I need to cut this out now. Thanks for watching, I hope you enjoyed, and space?